The Burj Khalifa used a revolutionary three-wing core to reach a crazy 828 meters high, making it the tallest building in the world. But now, get this, a new titan is rising, and it's using that exact same blueprint to aim for a height we once thought was pure science fiction, to become the world's first 1-kilometer skyscraper.
All right, so let's get right into this race to the sky. You've got the current record holder, the Burj Khalifa, and then you have the challenger, the Jeddah Tower, which is aiming to just completely shatter that record at over 1,000 meters. And this isn't just about stacking more floors, It's about totally pushing the boundaries of what's possible in engineering. So how on earth are they going to pull it off?
Well, the secret sauce for these megatall towers isn't just, stronger steel or tougher concrete. Nope. The real game changer is this brilliant, boundary-pushing idea called the buttressed core. And it's this design that gives a super slender tower its almost unbelievable stability. So what is a buttressed core? Think of it like a tripod. At its heart, you've got this super strong central hub, and that hub supports 3 wings, or buttresses. The whole system basically acts like a stiffened rod, which lets a really, really skinny building stand tall and strong against all the massive forces that are trying to topple it.
Okay, so here's how it works. It all kicks off with this hexagonal core. Think of it as the anchor for the whole thing, made of reinforced concrete. Then, stretching out from that core, you get 3 wings. But, and this is the really clever bit, these wings aren't just leaning on the core for support, they're actually bracing each other.
And that's where the genius of this design really shines. It's this perfect loop of support. The wings aren't just hanging off the central core, they're literally leaning on each other. And what you get is a structure that's just inherently, by its very design, incredibly stable and amazing at resisting any twisting forces. But even with a design this stable, there's still a huge challenge. Engineers have to face off against a skyscraper's #1 enemy. It's this relentless, invisible force that can threaten even the most massive buildings. So what's trying to knock it down? It's an invisible force. And the higher you build, the stronger it gets. It's a force that can make a gigantic tower sway back and forth so violently that people inside would feel sick. And in a worst-case scenario, it could cause a total structural failure. We're talking about the wind. This effect has a name. It's called vortex shedding. Okay, so as wind blows past a building, it creates these little swirls of low-pressure air, vortices, on alternating sides. And these vortices literally pull on the building, causing it to rock back and forth. Now, here's the dangerous part. If the rhythm of that rocking matches the building's own natural frequency, its own sway, you get this dangerous resonance. The swaying gets bigger and bigger and could, theoretically, tear the building apart. So how in the world do you fight something like that? Well, the engineers behind the Burj Khalifa had this aha moment. They realized that instead of just trying to brute force it with more strength, they could use a really clever architectural trick to essentially outsmart the wind. And the solution is actually pretty elegant. You mess with the wind's rhythm. If you're constantly changing the building's shape as it goes up, the wind can never get into a steady groove. That means those dangerous synchronized vortices just can't form. You are literally confusing the wind. Now, when you look at the Burj Khalifa, its spiral isn't like a smooth, perfect twist. It's more of a hidden spiral that's created by a series of steps and setbacks. Each level has a slightly different shape and profile, and that's what constantly breaks up the airflow and stops that organized vortex shedding from ever taking hold. Okay, so now that we've got the blueprint, let's look at how this proven, wind-confusing design is being pushed to the absolute edge to break one of engineering's biggest barriers. So the Jeddah Tower isn't a totally new invention. It's more like the ultimate evolution of the buttressed core. It takes that exact same tripod logic from the Burj Khalifa, the strong central core, the 3 wings, the spiraling setbacks, and just scales it all up to go after that incredible 1,000-meter goal. But, man, its journey has been anything but simple. Construction started way back in 2013, then it stopped completely for 5 years. But in 2023, reports came out that work on this desert giant has started up again, which means the race to that 1-kilometer mark is back on, and the Burj Khalifa's record is officially on notice. Think about this. If it's completed, the Jeddah Tower will be the first structure ever built by humans to break the 1-kilometer barrier. I mean, that's over 3 times the height of the Eiffel Tower. It is just a staggering, mind-blowing feat of engineering and ambition. So, after all that, what's the big takeaway from this amazing race to the clouds? What if we really learned about building higher than anyone ever has before? Here it is. Reaching a kilometer into the sky isn't about building thicker walls or using more material. It's about mastering that tripod geometry that turns a slender tower into an unshakable giant. You see, the secret to building super tall isn't about brute force. It's about the elegance of the structure itself, using these clever shapes to work with forces like wind and gravity instead of just fighting against them. And that brings us to a really fascinating final question. If this kind of elegant geometry is the real key to unlocking height, well, with groundbreaking ideas like the buttressed core now proven, how high can we truly go? It feels like the only real limit is our own ambition.